Hello, everyone. In this lecture, we will discuss about the actual data in machine learning or AI system. We will start with a very basic problem. I'll give you a use case and then why exactly machine learning was needed, and then the different kinds of data, which include tabular, image, text, and multimodal data. So, as we discussed in the last class, that machine learning is a six-step process, but there are three important pillars of machine learning. The very first one is data. Machine learning do require large amount of data, and data must be carefully prepared before the use. The second important pillar is compute. Machine learning models, they are computationally very extensive and intensive, and for this they require a lot of GPU and parallelization to train models efficiently. And finally is the algorithm. As I mentioned, there are different kinds of machine learning algorithm. This field of machine learning, development of machine learning algorithms is continuously evolving. Every now and then people are just coming with different algorithms. And generally, these algorithms plays an important role for a specific example or a specific use case that you are working on. The focus for this class is data. And for this, first, let's understand a basic business problem, which is the problem of book pricing. So if you let's imagine that you have a data set of books with attributes which include title, the author, the page count, the genre, and the sale price. And the sale price, you do not know about it. And um, you need an app, and that app will suggest the price for the book. Given you have all of these, which includes title, author, page count, and genre. The basic thing that you can come up is with a simple if-else condition. You can say that if the page count is greater than 200, I will suggest $30, versus if it is the opposite side, I will suggest $15. But what could be the problem? The problem could be that what if it is more than 1,000 pages, then $30 is slightly underpriced because it's a 1,000 page book. And the rule ignores also format, which is whether it is a hardcover or it is a paper bag, and it cannot be the same price associated with it. And what exactly is the genre? Because the genre does play an important, whether it's a fictional book, it's a non-fictional book, it's a romantic book, or something else. So a simple if-else condition will fail. So an argument could come in, what if we use complex if-then conditions, which includes that if it is more than 200, less than 400, and if it is non-fiction hardcover, I'll price $50. If it is non-fiction paperback, I'll cover $30 and whatnot. So you write all of these bunch of complicated rules. However, once again, this is also there is a problem associated with it. The problems which could be that it is not realistic. It ignores fiction sub genre, because in fiction it could be thriller, it could be literacy fiction, and it could have different prices. Similarly, the non-fiction subject may widely be, it could be a law textbook, it could be a popular science book. So once again, it doesn't fit for that particular use case. Similarly, a best-selling author would price it more expensive than person, no one knows. So if they are releasing the very first book. So there are multiple problems associated with it. So you need a solution which is scalable, which can come up with all of these different attributes of fiction, non-fiction, author, the price, the page count, and whatnot. So for this, we require machine learning model, because machine learning can understand the pattern, and they understand even the complexity. The more the data that you feed in, the more the features you have, the better the model can be. So your basic classical programming, which is rule-based programming, includes data and some rules, and it provides answers. However, in a machine learning, you have a data, you have an ML algorithm which will learn the pattern associated with it, and then based on a new data which is being fed in, it will predict or it will classify different kinds of model. This is the basic difference between classical as well as the modern machine learning algorithm. So the core component include data, ML algorithm, the ML model, and the new data. The data, it could be the historical information. ML algorithm could be some pre-built mathematical procedure rules that you would be writing. ML model would be the mathematical structure that capture the learned pattern. It is the output of the training, and the new data which you are training in order to make predictions or recommendations. That's how the machine learning model learn. So let's try to focus on zoom in on this data. As I mentioned, it is the past information which is required to make the machine actually predict. Uh, the data is basically the data has to be measurable so that you can make a prediction. There is also this term that we would be using, which is feature. Feature is a measurable attribute of a data sample. So a single feature is denoted by a lowercase, and a collection of feature, it's a vector, which is a capital case X. So a small feature, a single feature is basically this year that the book was released, which is 2018, versus a collection of feature would be it could be the year when it was released, the author name, as well as the page number. So this is a collection of features taken together, which is represented by vector, which is capital X. The feature selection is very important because it decides you that which features you need to include and which are important for your learning. So these are the two examples of a single feature versus a vector. There is a label, as I mentioned, in a supervised learning algorithm. It is generally denoted by a Y, a lowercase y, which is the sales price that you are predicting, which is what could be the possible price associated with these attributes or features that you are giving for the book pricing problem. So in this case, it could be $30, which is the predicted label that you want to predict that this would be $30. So data in machine learning is of variety of kinds. The very first kinds of data is a tabular data. So it's a kind of a CSV and Excel file that you store information in the form of numbers, text, and whatnot. So it's a table, and they are organized in the form of rows and column like a spreadsheet, as I mentioned, where each row is a data sample and each column is a feature. So that's the difference between this is the row basically means your data sample, and each of the column means the feature. The image one, sorry, the image data, which is the second important aspect, is it's an image file. And the features here are derived from the pixel values of that image or the spatial relationship. Photos of book covers, product images, they actually fall under image data. The next one is textual data, where it's a bunch of text which is written. It's a sentence, it could be a review, it could be a documents. And here the features includes words, character, high-level semantic rules. We will be mostly working on different kinds of data, but mostly tabular data just to make it easier. But we will also be looking at the other data set as well. There is a new concept which came in, which is multimodal data, which incorporates combination of data. It could include table, it could include text, it could include images. So all together, it can process everything. Large language model can process text, numbers, images, and whatnot. So it's a kind of a multimodal data. It can take audio and so on. Here, the label is generally could be a category that you can put in. So in this example, a multimodal data, it's a image. It includes the type associated with that image, as well as it includes the description associated with it. So it's a multimodal data. So in the case of, as I mentioned, in the case of a tabular data, it could be the features which are represented in the form of the columns, and the row represents a data sample, just very similar to the book pricing problem that we were discussing. Vector would be a collection of these features, which are these columns. So X0, X1, and X2 would be a combination of features, which is represented as a vector, and the label associated with a lowercase y. Image, for image, as I mentioned, image data set incorporates the image, which here the features are determined by the pixel value, whatever that image is, and the relationship associated with it. And the label would be what this particular image belongs to. So if this is a dog image, whether it's a cat image, that's what it's an example. So to understand this example in much more detail, this is an image of a raccoon, and here you provide as many images of these raccoon, and then you label them. This is raccoon 1, this is raccoon 2, and so on. So the algorithm tries to treat the raccoon pixel as features and uses them to learn and train the model. This is an example of your image. In the case of the text data, as I mentioned, it could be a long passage, a long sentence that you want to learn. So here, let's suppose it's a review of the book. So this book is pretty good. I would recommend it to my friends. So it's a long text of data. So here the features are text characters, or it could be words together. And the label is whether it is a positive sentiment or a negative sentiment associated with the review of that particular book. So here, this is a positive review because people have it has the words like good. I would recommend it to my friends. So you will put the words as a feature. So a single word as a feature. Bag of model is one kind of technique in order for us to understand and represent these text in the form of numerical numbers. And then finally, you associate a label to it that it is a positive label. Once again, circling back to the problem that we were trying to understand, how exactly machine learning model will actually learn. So we understood all of this, okay, they are complex algorithm, but we never understood what is the math behind understanding that complex pattern. So as I mentioned, the goal is to, a simplest machine learning model is a linear model where the prediction y naught is a function of x, which is the collection of all your features. And f of x is represented by a linear combination of all the feature values along with the weights associated with it. So these weights could be your the weights which you want to associate with your sorry, I'm having hard time accessing my slide deck. But anyway, so A0, A1, A4, AN these are the weights associated with the feature values. So feature were year sold, page count, genre, and so on. And A1, A0, A0, A1, A2, A3 are the weights associated with it. So what we can do is we can plug in, it's a weighted combination. We can plug in certain feature values as well as we can plug in certain weight. So the value 150, which is the 150 page book, you can input X1 as 150 over here, which is the number of pages for a given book. So here the prediction, as once again, you want to predict the actual label associated, which is the price for this specific example. So you will fit in all of these values which are related to your features. Here in this case, if it is a fictional book, you will make X4 value as a 1 because it's a yes label associated with, and you can fill the entire label. And then what you can do is you can assign this as a weighting mechanism. So I want to give page count a weight of 0.1 value, and for A4, I want to assign something else, which is 0.25, which is a fiction feature. And these weights are all random. It is dependent on how much your model can actually learn. And putting it together, once you put all these weights as well as the different number of features, you will have a magic number, which is 15.25, which is predicting that this particular book, which has the page count, which has the genre and whatnot, and you put down these weights, and finally you have predicted 15.25. So the now if a new value comes in, and if you have different page count, fictional value, and so on, you can have a different number associated with it. Once again, these weights are totally random. Finally, the key takeaway for this particular lecture I wanted to mention is that real world problem like book problems, they are often too complex for single crafted if else rules, and machine learning tries to replace a manually written nodes using some mathematical formulation. So we understood features, we understood labels, we also understood different kinds of data, which could be tabular, image, and text. We also understood what are the features as well as label associated with it. Thank you, everyone.